Let's have a look at question C in this video. So we have to consider the models from before, and we have to motivate why model 4 is preferable over model 3, and then we have to predict the revenue of a restaurant in an urban neighborhood with a median household income of $62,000 and low competition. So let's take first things first. Why is model 4 better than model 3? Let's recall what was the model. So over here we had regression lines for the revenues of a restaurant, and in model 3 we predict them based on the income effect and the city effect, so whether it's in an urban city or not. And in model 4 we added the effect of competition because we thought that that was an explanatory variable, that was a significant variable. And in the previous video we saw that we tested that with the F-test of joint effect, and we found out that indeed competition affects revenue significantly. So it's wise to include it in the model because our R-square increased significantly. So we have additional explanatory power. The data now feeds, the line of the regression feeds better the data. So that's why we would use the model 4. Now, with model 4 in mind, we have to predict the value of the revenue for what is given in the question, for the income of 62,000 and all that information. So let's use it. We know that the income has to be 62,000, and because income is shown in units, that's going to be 62 units because every unit represents $1,000, so that means 62 units for $62,000. We have the squared effect as well. We have it in an urban city, so that's a dummy variable which is going to take the value of 1 when we are regressing for an urban city. And then the competition has to be low, which is also going to be a dummy variable that takes the value of 1. And because the competition is low, by definition, this excludes the other one. It's not high, so this one will take the value of 0, and it will cancel out from the regression. Now, let's predict the value. So what's going to be the estimated revenue based on this model? We will have the coefficient, minus 2053.9. I'm not going to write, I'm going to round them like that, plus 139.7, if we round it up, it's 139.7 times the effect of income, the value of income is 62. Now we have to keep in mind we have the squared effect, which is negative because we have diminishing returns of income, so we have to take into account this parabolic effect. So we will have minus 1.1 times income squared. The value of income was 62, so it's going to be 62 to the power of 2 plus the value of 1, which is the dummy for the urban coefficient, is going to be 1 times the effect of minus 31.9, and then for the competition we have also the dummy of 1 times the effect of 64.7, and then this one has the value of 0, so we can also leave it out. Now if you work out the math over here, we would have an estimated revenue equal to 2,127.128 units. We are estimating in units because in the regression for the income we're also using data in units. But recall that every unit is expressed or represents $1,000. So if that represents $1,000, then we're going to multiply this number by 1,000 and get the value in dollars, because we would like to know what's the estimated revenue in dollars. And if we multiply this by 1,000, we would get $2,127,128 in estimated revenue based on this model with the data that we are given. Hope this makes sense, and we are done.